Welcome back, everyone. Thanks for being here. And thanks also to our presenters. It was a great slate of talks right now. My name is Joe Gasparetti. I'm a production engineer at Meta, and I'm the tech lead for Reliability Engineering, which is our internal group dedicated to investing in reliability across the infrastructure and the company. So I'm thrilled to have all of our speakers here today for a roundtable discussion. As part of my role working on reliability, I did have some some input, some contribution to access denied, the SEV that was talked about earlier in the day. And I know we had a question on that from the thread that we didn't get a chance to hit. So actually, I do want to pass it to someone at Meta to get to that question. So we'll kick it off by handing off to Joe. Joe, could you talk a little bit about the biggest change after the 2021 outages?
Yeah, then that was a hard one in particular because there was a DNS outage as part of that 2021 outage. So it was hard to investigate. The SEV and a lot of the access to our internal tools were limited during that SEV. And so, as Peter and Francois talked about this morning, we have a pretty strong incident response system at Meta. So we were able to look at what happened during that incident, talk about it afterwards, and improve. And so we had a couple of site outages earlier this year. We were able to learn from the ones that occurred further back in our history. And we had a much better ability to communicate and work on resolving the issue during that. And so I think our ability to resolve those quickly, even if we couldn't prevent them beforehand, we were actually able to mitigate them a lot faster. And the same thing, even with the ones this year, we get to benefit from the same incident response process. Discuss it after, figure out what we need to do, but then follow up over a longer term also and say, 6 months in or a year after, we're still working on the broader improvements that can prevent the issue from happening again, make it easier to mitigate when it happens again. I think it's like, as much a cultural shift in response to a big SAV or incident as like figuring out the technology that we need to improve.
So thanks for talking about that particular outage. We'll now get into the beat of the discussion, which is how we prevent these sort of things from happening in the first place. All of our talks were sort of about different phases of the pipeline, applied to databases, applied to code, how to check health, how to set up these pipelines. So I think we'll have a good discussion on that, and I look forward to going around the room. Maybe I'll start first with Tyson, since he has a bunch of experience building continuous delivery sorts of systems. And I was curious from your bio, just to kick it off, how is your experience in selling these sorts of continuous delivery systems on the open market different from, say, building the same sort of thing in-house for developers?
Yeah, good question, Joe. And first off, thanks for having me. Super excited to be here and be a part of this panel. Yeah, so I think, my view is when you're building infrastructure services, regardless of whether you're building for internal or external teams, the way you build those services and the way you think about service requirements is dictated by the availability requirements of your consumers. So, if you're in the kind of environments that I've been in where you're building for like super high HA services, you're going to follow all the same rigor in terms of the way you're going to do incident management, SLOs you're going to set. Obviously, SLAs, an actual kind of contractual details may be different when you're working with an external company because it's a different arrangement, but really same level of rigor. I'd say the biggest two things I'd think about, first of all, external, you're going to have less contact with external teams, so the communication is going to be different with those external consumers. That requires some thought, doing things like putting in place a customer advisory board of some customers that you're going to be higher touch with to really go deep and understand their use case. Thinking preemptively about communication during an incident. So for us, that means things like how we leverage status page, how we leverage support ticketing systems. It's going to be different because you can't just use your internal messaging software, use Slack or whatever to hit up an internal team. And then the other thing I'd kind of highlight is external teams tend to use your platform in ways that you don't expect because you're less familiar with their specific use case. And so that can make approaches like fuzz testing, for example, more interesting, where you're really kind of pushing the software with a wide range of inputs and not just kind of the ones that are top of mind for you as someone who's familiar with that internal use case.
Thanks for that. Actually, working in a big enterprise can sometimes be like working with the public. There's so many people
Yeah.
to work with. I'm sure some folks are familiar with. So in that vein, I'm actually curious to go into Chris and Anton's talk. One thing that you guys discussed was building health checks, allowing the people who write software within Meta to write health checks that then, determine whether or not the system is healthy during deployment. That's actually sort of a large scale problem. There's a lot of developers you have to work with. And you mentioned this concept of having high quality health checks. So I'm curious, how do you define health check quality? How do you go out to these developers and get them to improve the quality of their health checks?
Yeah, I mean, at the end of the day, I mean, especially at Meta, there's so many different types of services. And so quality is really something that has to be, it comes from tailoring the health checks to the service. And so, like, I mean, at the end of the day, what you're trying to get with a quality health check is that you prevent outages in production and you're not like unnecessarily stopping deployments. And so like that should be sort of like the end goal of a high quality health check is that, you're not wasting people's time by stopping their deployment and you're also making sure that production stays online. Um, but like, how do you actually categorize it and get the quality in a way that is usable by the deployment systems? Um, you know, but a lot of it is going to come down to sort of labeling and categorizing these things. Um, you know, like user actions that may happen during deployment. You can sort of take implicit signals from this and then work it into this sort of measurement metric that you then place on the health check. And there's sort of like a feedback loop that needs to be put in place so that this stuff kind of all works itself into, you know, sort of this mechanism that not only like prevents the outages, but also drives this incentive for service owners to like continuously improve their health checks. So yeah, I think there's no like perfect solution, but I think that's something that you have to continually strive towards. Uh, yeah.
Thanks for that. So Joe and Zach talked about RCV, regional config validation, in their talk, which is actually a specific example of a health check that has to be maintained and tuned. So I'm curious from their perspective, maybe Joe, could you talk a little bit about the effort involved on your side and on the team side to create that metric and maintain it? And what do you think about making that like scalable and sustainable?
Yeah. I mean, so the RCV metrics are super impactful. Like they're catching massive, site scale outages. So we're willing to invest a lot of human effort in tuning these. But one of the big challenges we have is how do we extend this technique to not just our largest, outages? How can we extend it to something that's a bit smaller, like even just a single product down? And that's where there's kind of a framing of like tiers of challenge. The most basic health check might be a metric like we showed in our talk with a line where if the metric goes above or below a line, a static threshold, then you consider the health check failed. Even just choosing where that line goes is something where we could benefit from automation and setting that line, automatically tuning that line lower or higher, right? If you're, for example, talking about like the memory utilization of a service, that might actually change over time. There's maybe like a step two of this of some of our health checks actually will do a test and control side. And so we might be saying, the test side can't, change more than a certain amount on any given code or config change. Tuning what is a threat acceptable change between test and control is another thing where it takes a lot of human effort today, and we would want to leverage some kind of automation. Then there's kind of the extreme of just taking any arbitrary metric, any arbitrary shape, and figuring out was that good or bad. And that's really the opportunity, I think, when we talk about removing the human altogether and figuring out what metric even counts as good or bad, what shape of a metric, associating it with the actual like deployment of the change. I think there's like a lot of opportunity there to solve and automate, but we're definitely focused on the earlier ones first, just getting it right with some of the more simple metric and threshold tuning first. That way we can apply these checks to more and more metrics over time without the human cost of maintaining every single one.
Thanks, Joe. On that topic, I want to bring Anton into the discussion. I have a question here about time windows, which maybe sounds simpler than it is. So what can you tell us about the most common time windows for health checks and how that affects the quality?
Yeah, actually, the time window is kind of trade-off between the quality of your health check or change safety setup and developer velocity. At Meta, we are pushing changes like thousands of changes every day, mostly continuously. And like when we're blocking the change, erroneously, it's bad, and we're affecting like hundreds, thousands of developers. And on the same time, sometimes it's not enough to have like only 3 minutes to evaluate what's going on with the system. So basically, based on our like results, we're using 10 minutes time window. It's really good compromise between like having good developer velocity and building good confidence in like what's the outcome of this change. Is it good or bad? It's also important to keep in mind that like we prefer gradual rollouts at Meta. So with 10-minute window for every phase, we're building confidence. Is this change good or bad? So actually it's 10 minutes, but it also depends on like many other factors. For example, criticality of the change we're rolling out, how many phases we're going to have, and it might slightly diverge from like 10 minutes to maybe 5, 15, but in average it's 10 minutes.
Thanks, Anton. I actually want to bounce back to a totally different domain, bounce back to Tyson. In your talk, you mentioned about writing tests on schema changes, and that warped my mind a little bit. How do I write a unit test on a database migration?
Yeah, so these tests aren't typically, when we talk about unit tests in this context, we're not don't typically mean something like making sure that the schema change was applied correctly in the database. We're kind of treating that, as invariant the system that the database will behave as expected. Usually I think what matters here, where you start to think about unit tests, is in the consuming layer just above the database, doing things like mocking out that data in the database. And writing a set of tests of that consumption layer that exercise enough functionality that you're going to see the effects of during a schema change. So actually going through, prior to deploying a schema change and auditing coverage at that consuming layer, I think is really important. And then beyond that, I think the kind of the next thing to think about, which was a topic in a lot of these other talks, a lot of interesting stuff there, is all up monitoring via canaries that are exercising kind of the full range of things that you expect a customer to do, in the live site during a schema change. And like I said at the talk, this is sometimes you have things going on in your production environment that aren't there in your pre-prod environments, no matter how real you try to make them look. And so, critical to have that kind of canary coverage at the broader level that makes sure there aren't cases that you missed at that lower level, via unit tests, and alert you to if there is something that would require a rollback.
Interesting. I'm actually curious, do you automatically roll back schema changes to databases given metrics?
Not typically, just because rollbacks are a hard problem. I mentioned I think in the talk I mentioned, databases are kind of the supremely stateful part of the application architecture. And so even the way that you think about a rollback is very different depending on kind of the nature of the data and the application and the capabilities that are available in your database. If you're fortunate enough to be working in a domain where some data loss is acceptable, a lot of times you can just snap back to a prior version of data and schema. And that's very easy in some modern offerings where they have this nice compute storage separation. You can just drop different block storage underneath your database. But if you can't accept data loss, usually you have to reason about what a rollback means. And there are kind of two strategies that I see, widely used that I think are good to think about. One of them is if you have a stream of changes, like a change log available, you can snap back and then replay those changes against the old schema version to get caught up. Or you can just view everything as a roll forward, which is what we often do in Fauna because we have these great migration tools that we provide for our customers. So you can just, even before the rollout, be ready to go with a pre-prepared, like imperative set of instructions on how to roll forward to get to the previous state. So those are kind of it's a lot of nuance, and I think it depends a lot. It's very, I think the reason not typically just automated is it's very context specific, and you have to be aware of the situation.
Interesting. I have a similar question on the thread for Zach. So Zach, have you explored automating rollout validation so that a human doesn't need to see a metric drop and then use Venn?
We have thought about it. It's a little bit tricky because most of our rollout methods already do consider like quite a few metrics during the rollout. The trick is knowing the right metrics to look at. So what we have actually considered is breaking up our rollouts to run each one with a random regional fingerprint. So run rollout to, 4 groups of randomly selected regions, and then letting anybody connect a specific rollout pattern back to a release and then interfere with or revert that release. This way, we can sort of do the discovery in the other direction in an automated way. So, given that I have a bad metric, automatically link that to a release. Because we have fairly good linking the other way. So, given a release, what are all the metrics that we think matter? But the reverse discovery is what's quite tricky.
Thanks for that. We have a question on the live stream now that I want to go to. I think it probably should be directed to Joe. And so the question is, do your canaries in various regions also include end users, like tests to see the overall business impact?
Yeah. So I guess the first thing worth noting is RCV is the backstop of all of our other protections. So we have validation and unit testing and kind of what you would expect in a release pipeline. And then RCV is that last step where we're running on a whole region. Now, when we talked about the different metrics that we run during RCV, ultimately all of these metrics come from actual user traffic going to these regions. So for example, like we talked about 500 errors. Those could be coming, those are 500 errors that would eventually manifest in a 500 error that's returned back to a user that's calling into our services through an application or website. So all of the actual metrics are derived from user traffic, and that is actually how we're able to measure the health of the change over time and then quickly figure out that the change is bad before it goes to all of our users. The user traffic is distributed across the different data centers and different hosts that we run all our services on.
Thanks. That's a good segue into a question from Anton that I have here. You mentioned about comparison thresholds. Why isn't it possible to use comparison thresholds every time?
It's a good one. So basically, it depends on like service topology and how we're performing rollout. So in many cases, like config canaries, early phases, and so on, it's like possible to find the actual control target where we're able to compare test and control targets. And it actually helps us a lot to build like great quantity that change either good or bad. But in some cases, it's not possible because we don't have enough traffic in our like control targets, or basically we cannot find enough signal from those. And basically in that case, we need to switch to static threshold. That might be not super accurate because basically, like Joe already mentioned, it's really hard to fine tune those static thresholds. But like the main reasoning behind that, even if we're not able to check comparison thresholds, we're still going to have some defense against like bad things happening via checking static thresholds.
Thanks. Okay, new question from the live stream. I want to make sure we hit as many of those as possible. This one's for Tyson, and it's actually a topic I'm curious about as well. Could you dive a little deeper on how you achieve zero downtime migrations? And the thing that I was curious about in particular is for high write rate data sets, how do you eventually catch up if you're trying to do this at zero downtime?
Yeah, it's a great question. It's tricky. If you think about kind of the state of schema, on one end of the spectrum, you have offerings like Mongo that apply like basically just write time schema checks, but never try to enforce that the entire collection complies with your schema. On the other side, you have like, let's say traditional SQL databases, MySQL, Postgres, where everything has schema, unless you're talking about JSONB. That schema is always enforced. And then the issue is, when you try to make schema changes, often the system will hold, there's this hierarchy of locks, and queries often result in locks being held while data is live migrated, which results in production downtime. The way that Fauna accomplishes, for example, which I think is pretty novel, is schema changes are transactional, and we apply schema changes just in time, subsequent to the schema change. So while data is being migrated, the transaction pipeline is looking at the effects of those imperative migrations that you've defined and applying them just in time, and then kicks off a background task to go and migrate data on disk to speed up subsequent queries. So, we're not alone in that. I think there are other players out there that are doing some interesting things here. But that's kind of I guess the way that we've unlocked that, what we think is a pretty important capability.
That's going on disk to migrate the data is interesting. I'm actually curious on that topic too. I have a question here. Why do you need to declare migrations when you talked about in your talk how you should be committing your schema to a version control system, and that is inherently a set of changes, a change log. So why have a migration, sort of way to define those on top of that when you already have the transaction log from your version control system?
Yeah, so I mean, first of all, Schema and Fauna specifically doesn't have to be in version control. We recommend it, but we don't dictate how customers do development there. And I think again, I want to give there's other tools out here where the same kind of philosophies apply, whether that's Atlas or Liquibase or whatever on top of a SQL database. In Fauna, what you're doing with when we declare migrations is actually looking ahead at the future to the state that you want to be in and applying that even out of band with committing to version control. So version control is going to show you a history of migrations that have been applied to the database. But there's nothing inherent to version control that's going to go say like, hey, I want to, add this column and manipulate data in this way to get to that, all this kind of set of steps that you want to apply kind of in the future. So that's the nuance there. But it is handy for looking back and understanding the history of migrations that have happened on your data.
Cool. Thanks for that. Okay, we'll take a bit of a pivot here to some other questions that we have on the thread. A little bit away from databases. We talked about time windows. I have a question here on I guess for Joe on the RCV runtime window. How did you come up with 10 minutes for that?
Yeah. A lot of that is empirical, I will be honest, right? So we actually we it's a little bit of trial and error to be honest, but we also that's the time window in which we can actually collect the data points, enough data points to be confident. You need a certain number of actual logged data points over time to be able to make some confident evaluation that those data points, a percentage of those, for example, are above or below your threshold. If let's say, for example, we went down to 1 minute, we may not have enough data points to get something that would be statistically significant or, kind of reasonable to avoid false positives. And then if we went, let's say, to 20 or 30 minutes, we would be blocking developers for way too long on any of their config changes. So we needed to basically pick the shortest possible window where we can get enough data points. And so maybe 8 or 9 minutes might be okay. We could consider actually going from a time-based evaluation to something where we actually wait until we have enough confidence and then move on. And so that's kind of one of the big problems that we could be working on in the future is saying, rather than just strictly measuring for a period of time, or I think Anton talked a little bit about, how long we wait to gather signal for health checks. We could actually say, we actually control our deployment based on the confidence we have. So if there are a bunch of changes going on at once and it's hard to necessarily tell what the health signal is, we could wait for longer before we push a change more broadly. Or if we have super high confidence, we could push faster if we get enough data in time. So 10 minutes, it's empirical, but it's what is the fastest we can do right now to get enough data points in to be confident about a change.
Thanks. There's actually some questions here I have on the thread about cultural topics, and picking a trade-off like 10 minutes is kind of that sort of thing. So maybe I'll go to some of those now. I have a question here for Chris. Why is it worth investing time to reduce false positive health check failures? I assume this is the sort of thing that you have to go around and convince people of. So how do we build a culture, how does engineering build a culture where people are willing to invest in this sort of thing?
Yeah, I mean, you have to sort of look at what the ROI is of these false positives, like fixing them. And like at least at Meta, there are thousands of engineers that are trying to make changes every day. And if the health checks are failing and there's no real issue, their changes are not going to be able to go to production. And so then now somebody needs to go and like manually look into this and kind of kickstart the build or the deployment to continue. And so this is time lost, right? And you multiply this by a large enough organization, and this is not trivial, right? And so I think like that's one aspect of it is, if you can reduce false positive failures, like and make them ideally only fail when there's a real issue, then it's gonna, you're gonna save everybody a lot of time. People are gonna be able to ship their changes faster. I think there's going to be higher trust in the whole, deployment ecosystem. And yeah, so I would say like you do have to measure the ROI, right? At some point, you might reach a sort of steady state where it's not worth trying to eke out that extra like optimal tuning setup. But I think in many cases there's always room for improvement.
Great. Thanks for that, Chris. And thanks to everyone who joined today. We're just about out of time. So I really appreciate that we had this forum here for you all to come and give your talks and hear from the audience. And I'm glad that we're building that culture of reliability, not just in individual companies, but across the industry. So good seeing everyone. Thank you.